So what we're going to do now is we're going to start by visualizing various hook methods in the Sequential SearchStreamGang program. And if you recall, these hook methods are basically the processStream and processInput hook methods that we talked about earlier. So let's go ahead and start by kind of giving an overview of where we are in our program. Remember, the SearchStreamGang program has a whole bunch of different implementation strategies that exercise a bunch of different interesting Java sequential, concurrent, and parallel processing strategies. And right now we're focusing just on the sequential stream strategy. So let's go ahead and talk about processStream. processStream is the entry point for the SearchStreamGang driver program. And what it does is it takes a list of input strings that it's given from the driver and then goes ahead and does some work to process and search the elements in those strings. So the first thing we're going to do is we're going to take this list of input strings and turn it into a stream of input strings. This should be old hat by now. We just use the good old stream factory method. That outputs a stream of input strings. Notice we haven't changed the type. We're still doing strings. Then we go ahead and kind of pipe that into the map intermediate operation. And map, of course, is going to go ahead and apply a method reference to every element in the stream, since it's a run to completion stateless operation, intermediate operation. And what it's going to do is it's going to call the processInput helper method, which is going to then search for the phrases in each input string. And everything is done sequentially here, of course. The results of the map intermediate operation will be a stream of search result objects. And notice here that we've changed the type. We've gone from string to search result. And that's because map has the ability to transform its input stream type into a different output stream type. And we're taking advantage of that in this particular case. What we have now is a stream of lists of search results. That's what comes out of map. And we're going to go ahead and collect these results using the collect terminal operation, which, as you will recall, of course, by now, will first trigger all the intermediate operation processing. So all the wheels start to run in motion. And then it goes ahead and it uses the toList factory method on the collector's utility class to create a list collector using ArrayList, of course. And that will end up converting the elements in the stream into a list of search results. And they'll be in the same order that they were encountered from whatever order the plays or the works of Shakespeare came in at the beginning when we first started the processing at the top of the slide. So that's going to give us a list of lists of search results. And we'll talk later about what we do with a list of search results. Before we do that, though, let's also visualize briefly the processInput hook method. So remember, processInput is called as essentially a subroutine of processStream. And what it's going to do is it's going to find where the phrases we're searching for may or may not appear in a given input string. So processStream is going to work on all the input strings. processInput is going to work on a single input string at a time. So it takes a list of phrases to find. These are all the famous quotes from Shakespeare. It converts that into a stream, sequential stream of phrases. And then it uses map in order to be able to go look up each phrase in the input string, the work of Shakespeare that we're looking at that particular point. So Hamlet, Macbeth, Julius Caesar, Romeo and Juliet, and so on and so forth. That will output a stream of search results, which may or may not have any hits. It all depends, of course, on whether those phrases are found in that particular work of Shakespeare. And because there could be plenty of good phrases that appear in some works of Shakespeare, but not in all of them, we're going to go ahead and filter so that we only include search results that actually had a hit. So if the search result that comes back from search for phrase is empty, in other words, there were no hits, we're just going to ignore that. So the filter operation basically will remove empty search results from the stream. So we have a stream of non-empty search results. We collect that into a list. So collect triggers all the intermediate operation processing as always. toList will create a list of search results. But here's what is important to note here, and there's a reason I'm doing things this way, so we can talk about this later when we talk about the flat map operation. Note that processInput might return an empty list of search results. Because if you're looking up certain phrases in the works of Shakespeare, they may not appear in that work of Shakespeare. So you may get back an empty list of search results. So keep that in the back of your head. When we talk later about flat map, you'll see how we use some of the semantics of flat map to implicitly filter out empty lists of search results. What we get as a result of map will be this stream of lists of search results, some of which could be empty. We'll deal with this when we get to the print phrases method. Print phrases is the method that actually prints out where the phrases appear in which works of Shakespeare. And we're going to see how it uses flat map to just ignore the ones that were empty. Right now, we're focusing on sequential streams that all run, of course, in one thread of control. And then later, probably on Wednesday, we will start talking about parallel streams, which will dovetail nicely with your next assignment, which is a parallel streams assignment. The cool thing to note here, and you'll definitely find this out for your assignment, is the fact that traversing or transitioning from sequential stream to parallel streams is as simple as going from stream to parallel stream as the factory method that you use on the various collections that you're dealing with. So the input work array or the input work list, the phrase list, you can trivially make those sequential versus parallel just by changing stream to parallel stream, which is really cool. So that's a quick overview, kind of visualizing how these methods work. What we're going to do next, of course, is actually walk through the implementation so you can get a better feeling for how you code this using Java features.